Hey, good people. Welcome back. This is Arthur Morris. In this video, we are going to look at solving nonlinear systems of equations by using the addition method. So remember, with the addition method, you want one of your variables to have exact opposite coefficients. So if we have two nonlinear equations like this, and you could have a linear and nonlinear, but if we have two nonlinear equations in a system, then one of the easier ways to solve it is by using the addition method. And you see we could have multiple solutions, or we could only have one solution. So it just all depends. All right, so here we have x squared plus y squared equals 8, and x squared minus y squared equals 0. So if you look at the y squared variable, then it already has the exact opposite coefficients. So if I call that equation 1 and equation 2, I don't have to multiply anything because I can eliminate my y squared variable. So be careful. Remember, this is 1x squared plus 1x squared, which gives us 2 times x squared. The y squares cancel, equals 8. Divide both sides by 2. X squared equals 4. Now remember, to undo the x squared, that exponent square, we want to take the square root of each side. And also keep in mind we have to um, keep in mind the positive and negative values when we take the square root in an equation. So when we take the square root of both sides, keep in mind that we have a positive and a negative value on that right hand side. So it could be positive or negative 2 for our x values. Alright, so let's check those. I will use equation 1, and let's find the y coordinates that goes with each one of those x coordinates. So if x equals 2, using equation 1, I would have 2 squared plus y squared equals 8. Subtract 4 from both sides. And just as we did with the x squared, take the square root of each side. And you see that y could be equal to positive or negative 2. So I have two coordinates that goes when with the x equals 2. 2 and positive 2, 2 and negative 2. Now how about when x equals negative 2? Again, I'm going to use equation 1 where we had x squared plus y squared equals 8. So negative 2 squared plus y squared equals 8. Negative 2 squared is positive 4. And since that is the exact same equation as what we just had there, I'm going to go straight down and say that y equals positive or negative 2 in this one as well. So when x is negative 2, y could be equal to positive 2, or it could be equal to negative 2. So we have 4 points of intersection there. 4 points of intersection. Okay, let's look at another one. All right, here we have 2x squared plus 3y squared minus 11 equals 0, and 3x squared minus 5y squared minus 7 equals 0. So to use the addition method, we want our constants to be on the right-hand side of the equal sign. So in equation 1, I want to add 11 to each side and rewrite equation 1 as 2x squared plus 3y squared equals 11. In equation 2, I want to add 7 to each side to move it over. Okay, so now we're using the addition method, so I need to pick one of those variables to eliminate. The only thing that catches my eye is with the y variable that I have a positive and a negative, so I already have opposite signs. So the least common multiple for 3 and 5 is 15. So I'm going to multiply equation 1 by 5 so I can make that y squared into 15y squared, and multiply equation 2 by 3 so I can make that y squared into negative 15y squared. Okay, now we are going to combine these two equations, eliminating the y variable. So we get 19 times x squared equals 76. Divide both sides by 19, and x squared equals 4. So again, we need to take the square root of each side to find that x equals positive or negative 2. Okay, so when x equals 2, using equation 1, then I have 2 times 2 squared plus 3 times y squared equals 11. So 2 squared is 4. 4 times 2 is 8. Subtract 8 from each side. Divide by 3. Take the square root of each side. So y equals positive or negative 1. So when x is 2, y is 1. And it's also at negative 1. What about when x is negative 2? X is equal to negative 2. And do the same thing. In equation 1, let's plug it in. Negative 2 squared is positive 4. And 4 times 2 is 8. Again, I see that I have the exact same equation, so I know that y is equal to positive negative 1 in this case as well. So my solutions are 2, 1, 2, negative 1, negative 2, 1, and negative 2, negative 1. Alrighty, let's look at one more example. Okay, so in this one we have x squared plus y squared equals 36, and then we have y squared equals, or y squared minus 3x equals 36. So what I notice here is that in both of my equations I have y squared, but I don't have x squared. So in using the addition method, I am going to eliminate the y squared variable. I want to rewrite my second equation though, and let's flip the negative 3x and the y squared around. Okay, so you see that both of my y squares has the coefficient of 1, but I need one of those to be negative 1. So I'll multiply my equation 1 by negative 1. This gives me negative x squared minus y squared equals negative 36. Equation 2, leave it like it is. Now be careful here. You cannot combine the coefficients on the negative x squared and the negative 3x. Just have to write those beside each other. We see the y squares eliminate, and negative 36 plus 36 is 0. Now again, I don't like having that negative as my leading coefficient, so I'm going to multiply both sides by negative 1 here, which all it does is changes all of your signs. Okay, so to solve this, let's factor out the x. Set each variable factor equal to 0. So x equals 0 is one of my coordinates, or one of my x coordinates, and the other one is x equals negative 3. Okay, as we've done with the previous problems, we need to find the y coordinates that goes with each one of those x coordinates. So using equation 1, when x equals 0, then 0 plus y squared equals 36. Y squared equals 36. Take the square root of each side. Y will equal positive and negative 6 when x is equal to 0. Again, to check those solutions, you would check it back into the other equation. So you could check this back into the second equation to make sure that it makes a true statement. All right, how about when x equals negative 3? Well, equation 1, we had x squared plus y squared equals 36. So negative 3 squared plus y squared equals 36. Negative 3 squared is positive 9. Subtract 9 from each side. And then find the square root of each side. So y equals positive or negative 27. Now 27, keep in mind 27 is the same thing as 9 times 3. So I can simplify that radical by taking the square root of 9. And that would be positive negative 3 times the square root of 3. So my other two solutions are when x is 3, then y is positive 3 times the square root of 3. And when x is, negative 3, then y is negative 3 times the square root of 3. Alrighty, good people. Hope you found that video to be helpful. I will see you on the next one. Thank you.